A huge hole in the sun's atmosphere points directly at Earth, blasting a stream of solar wind in Earth's direction. A huge hole has opened up in the sun's atmosphere, now large enough to be detected from Earth. The structure, located near the sun's equator, is about 500,000 miles wide, more than 60 times the width of Earth, and is spewing fast-flowing solar wind toward Earth. NASA's Solar Observing Satellite has captured images of a vast dark region of the sun's outer atmosphere in extreme ultraviolet light. The phenomenon can trigger small-scale geomagnetic storms that may enhance the auroras at high latitudes. Openings in the sun's magnetic field in these regions allow charged particles to escape into space at speeds of over 500 kilometers per second. Coronal holes are areas where the sun's magnetic field opens up, allowing the solar wind to escape and hindered into space. These regions appear dark in ultraviolet images because the hot, glowing gas that is normally trapped in the magnetic field is no longer trapped and flows out into space. They can produce moderate G1 geomagnetic storms, which represent disturbances in the Earth's magnetic field. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center classifies geomagnetic storms using a G-scale of intensity ranging from G1 weak to G5 extreme. SWPC said G1 storm conditions could cause minor fluctuations in the power grid and minor impacts to satellite operations. Migratory animals may also be affected at this altitude and above. The storm could also produce vivid auroras at high latitudes, including northern Michigan and Maine. However, it is important to note that space weather is unpredictable and difficult to forecast accurately, so geomagnetic storm warnings may be ineffective. Charged particles in the solar wind interact with Earth's magnetic field, exciting oxygen and nitrogen molecules in the atmosphere. This reaction creates the vibrant auroras commonly recognized as the northern lights and southern lights. A stronger influx of these particles can make auroral activity more intense and widespread. The impacts of a G1 storm are usually limited, but changing space weather conditions can alter visibility. During this geomagnetic storm, the auroras may extend further south than usual, increasing visibility in areas outside the polar regions. This energy is released as light, creating the colorful phenomenon seen in the night sky. The stronger the solar wind, the more dynamic the auroras become and the farther they extend.